11.4 hyperbolas. So when we look at hyperbolas, again, it will be the formula is important. In general form, we we classify between circle, ellipse, and hyperbola is this. Hyperbola has either ax squared minus by squared, or I miss out on another case, ay squared minus bx squared plus dot 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 equal to 0. Okay, so it could be two cases. The standard form is the more important one that you need to remember. The standard form, it could be x minus h squared first. Okay, it could be this first, x minus h squared first. If that's the case, then your orientations will be opening left and right on your hyperbola. Okay, if your standard form is y minus k squared first, then your orientations will be up and down. Your hyperbola will be opening up and down. The center is the same, h and k. Once you get the standard form, you will get the center right away. And you can see that when you draw right here is the center in our uh, graph, and this is the vertex when your hyperbola is opening left and right. And similarly, on hyperbola that opening up or down, these are your vertexes. So the formula you don't have to really remember, like I mentioned before, depending on your x first or your y first, you're gonna have to know it's gonna be opening left, right, or the hyperbola is opening up and down. Based off on that, you can adjust your vertex part. And when we graphing, we want to use like this strategy. First, you're gonna write it into standard form, so therefore you will know your center. Once you know your center, you're gonna plot the center first, and then from the center you're gonna count the value of a and b from the center to get a rectangular box. Okay, so that's the reason why up here, right here, all your the graph of the hyperbola has a rectangular box in a dotted line. That means like it should be like not there, but to help us graphing, we sort of like box that rectangular box. And then the next step, what we do is we draw the asymptotes which pass through the center and then the diagonal of the rectangular box. So these are the asymptotes that pass through the center and then go through the diagonal of the box, which will help you to see that how the hyperbola is gonna be behaving. Okay, because the hyperbola will be like drawing along those asymptotes. So let's take a look at on the example. Okay, so that is the best way to practice and learn. So first, both hyperbola and ellipse, the right hand side must be equal to 1. So therefore, when I divide both sides by 100, that will become 4y squared over 100 minus 25x squared over 100 equal to 1. And then this gives me, let me change the thickness. This gives me, when I simplify it, that will become y minus, right? K, my k in this case is 0 square over 4, and then 100 when you reduce it will be 25 minus x minus 0 square. 25 100 when you reduce it will become 4 equal to 1. So therefore I know that y minus 0 square over 5 square minus x minus 0 square 2 square over 1. So that tells me this is my first part. I put it into standard form already. And then my second part is finding out the center. So the center in this case would be 0, 0 because both of my h and k's are 0. That's my center. And then the vertex, and as I mentioned it before, the vertex we can leave it for now and then graph it first. So let's follow the strategy that I pointed out earlier. Okay, so vertex first plot the center. So that will be 0, 0 right here. And then you can account your A and B, right? You're going to count your A and B. So this is my y coordinate and x coordinate. So you can see that right here, your A and B, right? So the first number, this 5 is associating with y, so therefore it will be go up 5 from the center and then go down 5 from the center. And then this next value right here, 2, right? My b right here, that's my a and that's my b right there. 2 is associating with the variable x, so therefore it will be going left and right of the center. So it will be right 2 units and then left 2 units right here. And that will help me to get the rectangular box that we were talking about earlier. Okay, here. This is how you're going to be drawing the rectangular box after you count your A and B. And once you're done with that, that's where you're going to be drawing the asymptotes that diagonally passes through the rectangular box and the center. And diagonally pass it through the box and the center. Since y first, your orientation will be up and down, so my graph of the hyperbola will be right here like this, up and down. And therefore, we will get our vertex at this point and at this point. So my vertex will be, first one will be x is 0, my y is 5. And the second one is x is 0, my y is negative 5. And that will be the vertex that they're asking for. And now we got everything's in standard form. The vertex, the center, and then also the graph of it. So you have to remember, if y first minus x, y squared minus x squared, then the orientation will be up and down, right? Right here, I highlighted for you. If it is x squared first and then y squared, then orientation will be left and right on the hyperbola. So let's take a look at on the next example. So in this example, first I'm going to try to make the right hand side of equation to be 1. So I divide both sides by uh, 225. So 9. So this will be 9 x minus 3 squared divided by 225, and then minus 25 y plus 1 squared divided by 225 equal to 1. So now let's try to use your calculator. 225 divided by 9, that gives me 25. So it will be x minus 3 square over 25 minus, now that we know, it'll be y minus negative 1 square. 25 goes into 225 9 times equal to 1. So which gives us x minus 3 square over 5 square minus y minus negative 1 square over 3 square equal to 1. So this gives me my A and this is my B. So from here, we know that our center, that will be 3 and negative 1. My vertex, that's where we're going to be graph it first and then talk about the vertex later on. Okay. So graphing the center, plotting the center first, 3, negative 1 is right here. And from this point, you're going to count your a and b. Since a this time x squared first, your a is associating with x, so it will be moving left and right 5 units. So to the right 5 unit, to the left 5 units. And then b is 3 unit up and down, so 3 unit up and 3 unit down, which will allow me to get my rectangular box that we need to use for the draw the hyperbola. So we draw the rectangular box, and then the next step is we need to draw the asymptotes that pass it through the center and the diagonal of the rectangular box. That will help me to get the behavior of this hyperbola. And since x squared first, these will be my vertex, and then our graph will become getting closer and closer to the asymptotes. So as you can see, this is how the graph of this look like. So my vertex, finally, it will become my x coordinate. For this one, my x coordinate is -2, my y coordinate is -1, and the other ones will be my x coordinate is 8, my y coordinate is -1, and this will be my final answer for this. So the next example that we're going to look at is where you need to complete the square to get the standard form. Right? So let's talk about example number 3. So to complete the square, first I'm going to try to rearrange my x variable part. So it'll be 9x squared plus 18x. And then arranging my y variable part, 16y squared plus 64y equal to at 199 to both sides. Now, in order to complete the square, the leading coefficient must be 1. So from this first group, I need to factor 9 out. From the second group, I need to factor out -16. So when I factor it out, it will be 9 out x squared plus 2x, right? 2x. And then for the second part, if I factor -16 out, it will be y squared minus 4y and equal to 199. Now what we're going to do is we're going to find out the number that needs to add in order to get the perfect square trinomial for x and y. So if I'm looking at for x, b squared divided by b divided by 2 and square it. For the x part, that will be 2 divided by 2 and squaring it, which is 1 squared is equal to 1. So I'm going to be adding 1 for x. But on the right hand side, because of I'm adding, I need to remember that factor 9 in front of it, like in ellipse. So we're going to be adding 9 times 1, right? Eventually you are adding not 1, you're adding 9. And then the next one, for the y part, it will be again b divided by 2 and squaring it, which is in this case -4 divided by 2 squared, which is -2 squared equal to 4. So you are adding 4 to it. But eventually what we are adding is plus your factor right here is what? -16, right? -16. So it'll be -16 times -16 times 4. So that's what you eventually adding to it. So you have to be careful with those factor in the front. You cannot forget that. Otherwise, your hyperbola, your standard form will be messed up, and then your graph and everything will messed up. So finally, we got a perfect square trinomial already. So therefore, rewriting it, it will be 9 times x plus 1 quantity square minus 16 times y minus 2 quantity square is equal to, on the right hand side, when we simplify using the calculator. 199 plus 9 minus 64, that gives me 144. So now I need to make the right hand side 1, so I divide both sides by 144 and divide by 144, which give us, so reducing it, 9 and 144. So when you 144 divided by 9, that gives me 16 minus, so therefore right away I know that 16 goes into 144 9 times as well. So finally, if I rewrite my final step, this will become x minus a negative 1 square 4 square minus y minus 2 square over 3 square equal to 1, which tell us our center, right? Our center is basically going to become negative 1 and 2, and this is my A and this is my B, and because of x first, the orientation will be left and right. Vertex, right? The vertex, we always come back and then get the vertex at the end. So first, plot in center first, negative 1 2, which is right here, and then you count your A 4 unit to the left and 4 unit to the right, which will give me, you know, part of the rectangular box, and then you count your B 3 unit to the top and then 3 unit to the bottom. So finally, this helped me to get my rectangular box to draw the diagonals, and then therefore I will get my hyperbola. So let's draw the box first, and then the diagonals, right? Asymptotes that go through the diagonal of the rectangular box and pass it through center. So this will be like this, and this makes it, since this is x squared first, the orientations in left and right, and my vertex points are right here. Now we draw the hyperbolas, getting close to that asymptotes, and then finally we can write it down our vertex, which is on the right side will be 3 2, and the left side will be negative, excuse me, the left side will be negative 5 2, and this is our final answer. So in summary, we know that if the parabola is y is x squared, then the parabola will be opening either upward or downward. If it is x is equal to y squared, then we know that the parabola will be opening left or opening to the right. For the circle, in the general form, a squared plus b squared, where a and b are the same, right? That's how you know the difference between the circle and ellipse, because ellipse is also a squared plus b squared, but however a and b's are what? Difference. And hyperbola is easy because hyperbola will be a squared minus x squared minus y squared, or y squared minus x squared. So either one of the cases. Okay. So this will be the end of this sections. Hopefully you can uh, remember these formula. Okay. Remember these formula by by the day of the test, and then I again happen to have like both of them is a side left and right of parabola on the orientations, except this one. So practice